So let's go over factoring quadratics, specifically quadratics and trinomials. So we know that a quadratic is written in the form ax squared plus bx plus c is equal to 0. Setting a quadratic equation equal to 0 helps us find our solutions, our roots, or we could also say our zeros. So let's work on one function here. Now we're going to first start with quadratics, where a is equal to 1. So let's focus on x squared plus 10x plus 16. So here, right, I'm just going to write that imaginary number 1 in, and I'm going to multiply those two numbers. By those two numbers, a and c. So 1 times 16 is 16. So think about what numbers multiply to 16 that add up to our b value of 10. Just write that up here. Keep it more consistent. And so if you need help factoring or figuring out what those numbers are, just list out all the factors of 16. So I know 1 times 16 gives me 16. I know 2 times 8 gives me 16. And I know 4 times 4 gives me 16. So which of these pairs multiplies to 16 but adds up to 10? So 1 plus 16 is equal to 17. 2 plus 8 is equal to 10. And 4 plus 4 is equal to 8. So I'm actually going to take this pair here, 2 and 8. So x squared plus 10x plus 16, that's going to equal to x plus 2 times x plus 8. And let's say we want to find these solutions, these zeros, these roots. So this should be x plus 8. So that means x plus 2 is going to equal to 0, as well as x plus 8 is equal to 0. Remember, any number times 0 is going to give us 0. So it could be any of these two possible solutions. And so for x plus 2 is equal to 0, I'm going to subtract 2 from both sides, and that should give me a 0 at negative 2. And if I subtract 8 on both sides for my second binomial, I know that x is going to equal to negative 8. Well, what if our a value is greater than 1. So instead of a equaling to 1, we have in this example where a is going to equal to 6. So we're still going to do that first step of multiplying our a and c values together. So 6 times negative 10 is going to equal to negative 60. So think about what two numbers multiply to negative 60 that add up to 11. Now here, since we're multiplying two numbers that give us a negative number, we're going to get one number that's going to be positive and one number that's going to be negative. So I'm going to write out all the factors of 60 as I can. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12. We also have here 6 times 10. So I'm going to stop there for now, and let's just see which of these will multiply to negative 60, but give us an answer of positive 11. So what that means is that the integers are going to be about 11 units away from one another. 6 and 10 is not 11 units away. Neither is 1 and 60 or 2 and 30. 4 and 15 here, they're 11 units away. Luckily, since the b value is positive, that means the 15 is going to be positive. So this sign tells us here for the b value, the larger integer is going to have this sign. So it's going to be plus 15 and negative 4. And so we're going to rewrite this function, this equation rather, as 6x squared plus 15x minus 4x minus 10 is equal to 0. So you should get 4 terms here now. And now we're going to factor these. I'm going to group these two together. And the third and fourth terms together. And I'm going to take the greatest common factor. In other words, I'm going to take the greatest common factor of both the integers and the variables. So the greatest common factor of 6 and 15. So 3 would be the GCF there. And what goes into both x squared and x? X does. So I can factor out the x. Minus. And the GCF of 4x and negative 10, I'm going to take 2. It's going to be minus 2 times. And now we're going to figure out what goes inside these parentheses. So 3x, I need to figure out what, if I'm multiplying with 3x, gives me 6x squared. So I know 3 times 2 gives me 6, and x times x gives me x squared. And what would I have to multiply with 3x to get 15x? Well, that would just be multiplying it by 5. Good. So now for this second binomial, 2 times 2x gives me 4x. Remember, we have this minus sign out here, so negative 2 times 5 would give me negative 10. And you'll know you're on the right track here, where you'll see here, and let me just use the highlighter, you'll see that these two binomials are exactly the same. And so that's going to be one of your factors here. Let's go back into our pen here. So 2x plus 5 times, what's going to be the other binomial? Well, let's look at these two terms that are multiplying on the outside of these binomials. So 3x minus 2. You'll set these equal to 0 if you need to find the roots from here. How about with completing the square? Let's say we have x squared plus, let's choose a good number, plus 10x plus 3 equals 0. Okay, I'm going to multiply the a and c values. So 1 times 3 gives me 3. So I'm finding what two numbers multiply to 3 that add up to 10. And what you notice here is there are no numbers that multiply to 3 that add up to 10. That's where you'll be completing the square. So you have x squared plus 10x. I'm going to remove this plus 3 for the moment. I'm going to move it towards the right side because I want to create a new third number that's going to work there. That's going to equal to negative 3. And in order to find a number that works perfectly in here, I'm going to take the b value, which is 10, and I'm going to divide it by 2 and square it. So that means I'm going to take, sorry, there should be an x here. So 10 over 2 squared, that's going to equal to 5 squared, which is going to give us 25. So if I'm adding 25 on the left side, I'm also going to add 25 on the right side. This is going to be a perfect square binomial once we factor this. What two numbers multiply to 25 that add up to 10? That's going to be 5 and 5. So x plus 5 squared is going to equal to, let me simplify, negative 3 with 25. That'll be 22. And so now we're going to solve for x. And I'm going to take the inverse of squaring something, which is going to be the square root. And so removing the square, we're going to get x plus 5 is going to equal to plus or minus square root of 22. Finally, subtracting 5 from both sides, x is going to equal to negative 5 plus or minus radical 22. I'm going to take that same problem from earlier, and let's say that we choose not to complete the square, but instead to use a quadratic formula. So x squared plus 10x plus 3 equals 0. We're going to list out the a, b, and c values of this quadratic. A is going to equal to, I see a hidden number next to this x squared, a phantom 1. So A is going to equal to 1, B is going to equal to 10, and C is going to equal to 3. Make sure that if these two numbers were negative, for example, if it was minus 10x, then we will place here a negative 10 here. You take the sign that's next to that specific constant or coefficient. You're going to write the quadratic formula. If not, it should be provided for you for that problem. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And now I'm going to rewrite the quadratic formula, but now I'm going to be substituting in those a, b, and c values. So again, let's plug those values in. So negative 10 plus or minus 10 squared minus 4 times my a value is 1 and my c value is 3. And our a value 2 times 1. And now we're going to simplify here. So x is going to equal to, that's going to be negative 10 plus or minus 10 squared is 100 minus 4 times 1 times 3, which is 12, over 2. Again, that's going to simplify to, if I move right up here, negative 10 plus or minus the square root of 88 over 2. How can I simplify that radical 88? I know it's not going to be a perfect square number. So I'm going to try to find a number, or two numbers rather, that multiply to 88 where one of them can be simplified. So for example, radical 4 times radical 22. And so I know that radical 4, that's going to be simplified there. Radical 4, the square root of 4 is 2. So I have negative 10 plus or minus 2 radical 22 over 2. And luckily, 2 could be divided amongst the negative 10 and this 2 radical 2. So negative 10 divided by 2, that gives me negative 5 plus or minus, and those 2's are going to cancel out there. So it's going to be negative 5 plus or minus radical 22. And so completing the square, by using completing the square and the quadratic formula, we should be able to get the same factors. That's what I got here by using the quadratic formula and by completing the square. We got this value here of x is equal to negative 5 plus or minus radical 22.